So, do you want to make a tactics game like Fire Emblem, Final Fantasy Tactics, XCOM, Disgaea, Battletech, or you are feeling a little nostalgic for something like Front Mission, or you are truly the coolest man alive and remember Jagged Alliance? All of those games share similar systems between each other. All of them use grid map for movement. Some of them use hexes instead of squares, but overall it functions the same. In this series, I will be covering the way to make a tactical combat game with some simulation aspects of other titles. Main aim is to make combat works, then I will build on top of it. As a main inspiration I will be using Fire Emblem series of games, mostly Fire Emblem Three Houses, which I desperately want to play, but I don't own Switch. So to be fair, I'm mostly basing my knowledge on YouTube videos and Fire Emblem games from 3DS and Path of Radiance. But if you want to make XCOM or something else, don't click away. As I said, those games are very similar in many aspects, and it will be possible to adapt what we are going to do to make any other tactical game you want to make. This tutorial will use Unity of version 2021, and it should be workable on any other versions later on, with maybe slight minor changes. We will be using URP as a main renderer. If you encounter any issues, make sure to first check the pinned comment. All people make mistakes, and I'm not an exception. If I make a mistake or need to add a correction, I will be posting the correction in the pinned comment. If there is no pinned comment which helps you, leave a comment or join the Discord, and I will try to help you as much as I can. If you follow my channel, you might know that I already have a series dedicated to grid map, which we will be making in this tutorial. Yet in that series I were making 2D top-down grid map. This series will be making a 3D map. Please leave a like and a comment if you like this series. If you really want to support me, I have Patreon in the description. And we have a nice comfy Discord server where we can chit chat and share joy. So join in the link in the description. Good, let's go everyone, stay strong. Today we will begin with setting up the grid. Remove readme file, and let's begin. Create an empty object and call it a grid. Create a new script called node. And create another new script called grid. Open node script. Because node will not be a component, remove monobehavior inheritance. Every component, like this grid, is derived from monobehavior. So if you try to attach the node like component to this grid object, it will not work. Back to node script. Declare one public bool variable called passable, which will mark the node as being passable by character or not. Now open grid script. So to define the space where our character will be able to move, we will create a 2D array of nodes. Now we need to define the size of the grid space. Create two variables, width and length of the map. Actually, let's make them serialized fields, so you will be able to modify them in the editor. On the start, initiate the node array. Let's make some kind of area out of floor and few boxes to represent playing field. Good, now we have a space to play around. Open the grid script. We need to describe the size of each node in the world. For this, we need to define the size of each node, create a serialized float variable called cell size. Now we want to visualize our grid. In onDraw gizmos, cycle through width and length, and using gizmo square, draw the nodes. Calculate the position of the node in the world space. Draw the gizmo. Now you can see the nodes on the scene. Let's make them smaller. And if you move your grid object, it will change the point of origin of those nodes. It will make adjusting the grid easier when it needs to be done. Now we have a grid visualized on the scene, but right now the grid itself actually is not populated with actual data. We are just using the size of the grid to draw it on the scene. What we need to do is to populate the grid with data, based on the scene we have created. To populate the grid with data about possible terrain, we want to block out the impossible terrain. You see, instead of selecting individual nodes and assigning the values that this node is impossible to traverse, you can define that certain colliders on the scene represent the area impossible to move through. In our case, it is simple, just those walls. Let's move them to a new layer called obstacle. What we will be doing now is detecting if the node collides with obstacle. If it does, mark it as an unpassable node. So on the start, create and call generate grid. Initialize grid inside generate grid instead of start. Inside, call and create a new method called check possible terrain. Cycle through width and length of the grid. And here we want to use checkbox to determine if the area is passable and not obstructed by obstacles. First parameter will be a world position. We already have world position calculation in the onDraw gizmos, so to not repeat ourselves, let's extract it into the method. The automatic extraction inverted the parameters. Let's fix it. Then we have a half extent of the cube we will be projecting. Simply divide the vector3,1 by half, because it is half extent of the cube, and multiply by the cell size. Third parameter is the rotation of the cube in quaternion. Simply pass quaternion identity. We don't need any angle here. Last fourth parameter will be our layer mask, where we can pass the layer of our obstacles. Create serialized variable for this layer. Layer allows us to ignore all other colliders, which is not obstacles, for determining is this node passable or not. Now we want to visualize passable and impossible nodes. In the onDraw gizmo, create exit gate if the grid is null. So gizmos will not be drawn if the grid is not initiated yet. Then check if the grid node in position passable, make it white, otherwise red. Now before we proceed, we have determined if the area for the node is passable, but we haven't assigned the state to the grid. Initiate the node and assign passable value. In the editor, assign the obstacle layer and launch the game. This error is happening because when we are checking the box, it returns true if it collides with something. In that case, it returns true, which in our case should be inverted, because our variable is called passable, not an impassable. And now our grid is easily scalable and easily changeable. You just need to move objects with an obstacle layer. Good. This is a good stopping point for tonight. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. Special thank you to Andrew B. Long for his generous support. With best regards, see you in the next episode.